So let me start first with the window. So window is nothing, very simple, because you already know vapor compression cycle. Na? So in window AC, you'll find all the four components of the VCR, and this is the best example of vapor compression cycle. And you see, this is commonly used in actual practice for small spaces, single rooms. Okay, and it's a cost effective. So that's the reason, and it's like a plug and play, no separate installation. We require some installation procedure, but not like the other units. Okay, so that's the reason for small spaces or small rooms, this is commonly used. But technically, if you talk about this window, you'll find the four components. I'll play one small video, you'll get the clear idea. Because anyhow, you know this vapor compression cycle. No? You see what are the components in window? The same components. You'll find the compressor, the condenser, expansion device, and a evaporator. And you'll find a motor with the two shafts. One shaft is used to rotate this axial fan, and the other side shaft is used to rotate this blower. The same for the same motor. And you'll find the partition in the window. This side is inside the space, and this side you need to place outside the building. It does not mean that we can place in between the two rooms. No, this side must be outside, because this is the condenser side. The heat rejection is required, and this side we can place inside the room. So the same cycle, vapor compression cycle, you know what will happen in vapor compression cycle: compression, condensation, expansion, and evaporation. So this work on the same, but we have some points to discuss. How this temperature means after maintaining the required temperature, how the system controls. Because you see, continuously it will not run except the fan. The compressor will not run continuously. After maintaining the required temperature, the compressor will off. Means it will work in a cycle, on and off. I'm not talking about the fan. Fan will run continuously. When you switch off, then only the unit will off. Or else when you switch on, the fan will run continuously, but the compressor is going to be work in a cycle as per the required temperature in the space. But how it can be done? By continuously measuring the return air temperature. But where you'll find the return in this? You see, this grill is for return and this is for supply. This is for return air and this is for supply. Means suction from this side and supply from this. And backside of this, I'll show you in the video. Backside of this, you'll find which coil? The evaporative coil or the condenser coil?
Evaporative coil.
You'll find evaporative coil, right? Before evaporative coil, you'll find sensor or a temperature bulb, which will continuously monitor the return temperature. And according to that, it will give the signal to the thermostat, and the thermostat can operate the compressor on and off. So suction from this side, and it will pass through what? Evaporative coil. And you know, when the air passes through the evaporative coil, it loses the heat and the moisture, right? Can you see these droplets? Condensation. So at the outlet of this unit, this is the supply side, you'll get what? Cool and dry air, right? Okay, so continuously, so you see this section, in this section the room air circulate, and in this section the outside, the air suction from outside and throw on this what? Condenser coils to reject heat by using the outside air, and it is rejecting to outside only and rejecting the heat from the condenser. You know the process. The refrigerant will change its phase from vapor to liquid. You know the process. This is, and I'm not explaining again. So the same vapor compression cycle inside this, but the high side is outside the building and the low side is inside the building. So one can install in the window or a special opening in the wall as per the requirement. It's a simple concept used in actual practice. So we'll discuss the advantage and disadvantage. Then I'll play a small video so you'll get the clear idea about this window AC. Some important points, what I explained just now, the sensor, return air, and how exactly I'll show you in the video also. You see the capacity available 0.5 to 2 TR. I'm talking about in general. In most of the location, you can find this in the range of 0.5 to 2 TR. In some location, you may find 2.5, 3 TR also. Okay, so in general, if in for interview point of view, you can use this 0.5 to 2 TR. May vary as per location, as per the location and as per the vendor also from your location. Next, if you talk about the advantages, you see it's a compact unit, right? So we have space saving design, and it's like a plug and play. Simple installation process required, and no brazing or no connection of copper pipes like split is not required in this. We are not disturbing any component inside, simply just installing in the window or in the opening, and we are switching on with the proper or with the required electrical supply. It will start working. So space saving, easy installation in the video or sorry in the window or in the wall opening. Ideal for renters or those who don't want to make the major modification to their homes. Suppose if you decide to go for air conditioning after completing the painting and all, I'm talking about the small project. For big project, the case is different. And if in case if in the existing flat or is this existing home, if you want to go with the split, so in case of split for running the pipe, split means you'll find two units, indoor and outdoor. To run the pipes, the wall chipping is required, taking the pipe from indoor to outdoor. So that modification work is required as per the site condition. But in case of window, only opening is required. Next, can be used as a supplementary cooling source in large spaces. Sometime the design, if the design is undersized, or sometime, suppose if you design a classroom for say 20 students, but for some cases, some special classes, some special seminars or workshops, suppose 30 people in that area, so we have not designed for that. So in that case, one can install this for special cases. In that case, one can use this as a additional cooling for large area instead of changing the existing system. Or in some cases, if the system is undersized, one can use this one like retrofittings. Next, if you talk about disadvantages, you see this is for small rooms only because the capacity is limited, 0.5 to 2 TR in general. So it cannot be used for the large spaces. This is for small rooms, or in many location we used to call this as a room AC. Window AC also known as a room AC, okay, or a single AC. So don't get confused. So cooling is limited to a single room or a small room, and you see may obstruct window and reduce natural light because the space is required in the window, so it may disturb the window. Next, appearance point of view, it look ugly because outside the building as well as inside the room, it will affect to the appearance. So interior point of view, it's not an interior choice. The interior will not in most of the project, the interior will not accept this. They ask for the cassette, or they ask for I'm talking about a split. Under a split you'll find cassette or high wall. So for interior point of view also we have this disadvantage. And noise, this also one major disadvantage. The compressor is very close to, means with the compressor within the unit, and the unit is in the room. Just that condenser or the compressor side is outside, but within that unit only, so when you use, it will create a lot of noise like air cooler. Okay, so noise point of view, I'm not talking about all the units. We have some advanced options in there, you'll find no noise. But you see, window itself is with a limited capacity, so you in many manufacturer you'll not find the on this high class type in that, because this is not a for high class. You can expect in cassette, sorry, in you can expect in the split system. So normally you'll find a lot of noise when you operate this one, and noise means, this is one of the parameter for air conditioning, maintaining the noise level less than 35 dB. So it will not satisfy the all parameter of air conditioning as per the definition of air conditioning. So you can consider this as one of the major disadvantage in this. Okay, apart from this, in window, even in split, you cannot expect the standard fresh air. In window, you'll find some option for fresh air in some models, not in all the models, but still that option is not as per standard requirement for to satisfy the fresh air requirement. Okay, so ventilation is not as per standard. This is also one major disadvantage of this window. So let me quickly one small video clip. You'll get the idea.
While air conditioners can differ from model to model,
Yeah, please have a look.
air conditioners can differ from model to model. They all operate on similar principles. In this video, we will address how an air conditioner operates, as well as potential problems you may encounter. When you switch the air conditioner on, the thermostat control sends 120 volts of alternating current to the compressor and the fan motor. The compressor acts as a pump, compressing refrigerant in gas form into the condenser coils, located near the back of the unit, where the gas is condensed into a hot liquid. The condenser coils dissipate the heat as the liquid travels through them. Once the refrigerant has passed through the condenser coils and the capillary tube, it travels to the evaporator coils, located near the front of the unit. As the refrigerant liquid enters these coils, it expands into a gas, which makes the coils cold. The gas flows through the coils to a suction line attached to the compressor. The compressor converts the gas back into a liquid, and the cooling cycle continues. At the same time, the fan motor rotates a blower wheel.
You can see here only one motor with the two shaft. One shaft is connected to the blower, which is inside the room. Other shaft is connected to the axial fan, which is used to cool the condenser with the forced convection,
which draws in air to be cooled by the evaporator coils before recirculating it back into the room. The same motor also operates the condenser fan blade, which blows outside air through the condenser coils to cool them. The air temperature is regulated by the thermostat control. Depending on the model, the control may be a thermostat switch and sensing bulb assembly, or an electronic control board that works with a sensor. The sensing bulb or electronic sensor.
You see, this is important. The sensing bulb you will find when you remove the front panel, means before this evaporator. This is related to evaporator side. So it means, you see, when the suction take place, it will pass, one minute, it will pass through this, and you see this strips are fins, and in that you'll find the coil. In that you'll find the coil. So this is a cooling coil. So the suction from the room passes through this, and continuously this sensing bulb will monitor the return air temperature. Okay. And monitoring the return air temperature can control the compressor. But how? For example, suppose assume that you switch on the window AC and you set the temperature, say 23 degrees centigrade. In the window, with the window, you'll find the remote also, or else the manual. You can set that temperature, the required temperature, 20 degrees, 3 degrees centigrade. And assume that the present room temperature, say 30 degrees centigrade. So what will happen when you switch on this unit and setting this 23 degrees centigrade, you'll get the cool air. And the room temperature start decreasing now. Okay. So 30 to say 28, say 25. So after some time, you can expect this room temperature, say 24, and further say 23, what we set. Okay, we have plus or minus say 1 degree centigrade or 0.5 degree centigrade, throttling range. So when 23 is attained in the room, so what will happen in the return air also, you'll get the same temperature, na? And you see, continuously this sensor will monitor the return air temperature. When the return air temperature same as what you set, what will happen? This bulb is continuously monitoring the temperature, giving the signal to the thermostat. The thermostat will cut off this or trip the compressor. But the fan will not stop. The fan will run continuously. And the continuous process, after some time, the compressor is off now, so only air is supplied, not the cool air. After some time, the temperature may increase. Suppose 23 is to say 25, or say 24 or 25. And this is continuously monitoring the temperature now. So when the temperature increases, again this bulb continuously providing the signal to the thermostat. When the temperature increases, again the compressor will on and supplying the refrigerant to supply the cool air. And remember, this concept is not only for window, even for split or ductable split, or even for chill water system, FCU or AHU, you'll find the same concept. So I request you please make a note of this. Please make a note. Window, comma, split, comma, ductable split. At this level, I'm not adding chiller because in chiller we have air side control and water side control. But again, air side control, the same concept. Okay, so window split, ductile split, and if you want, you can write chiller air side controls by means of return temperature. By means of return temperature, and this can be asked in interview. Or in short, I can say return temperature responsible to control the compressor on and off for window split or ductable split, etc. This is an important point. Next.
Is clipped to the front of the evaporator coils to monitor the temperature of the air entering the coils. Once the room has sufficiently cooled, the thermostat control shuts off the voltage to the compressor. Some models which use a vent can operate the fan motor.
You see, this is a fresher option in some models, not in all the models in window.
Only to draw in cool air at night. However, when the appliance is actively cooling the air, the vent must be closed for the system to work properly. Be aware that it's normal for water to collect in the
You know about this. From where we are getting this water? This water because of condenser or evaporator?
Evaporator.
Right, evaporator is the correct answer. And now the source of this water?
That moisture content.
Means from the room air, right?
Yes.
bottom of the air conditioner when the appliance is running. A slinger ring on the condenser fan blade picks up this water and sprays it onto the condenser coils to help the coils dissipate the heat.
And you see this spraying the water on the condenser coil, you'll not find in all the models. In some models you'll find. This will help to increase the efficiency. The same condensed water, because it is going to be available in the same drain tray at the bottom, so it can be utilized to cool the condenser to increase the efficiency, but not in all the models.
To prevent the water from dripping into the room, the appliance should be tilted.
This is also important point. The drain water must be through outside, or else you will get the leakages inside the room. So at the time of installation, we are maintaining slight inclination, like say 5-degree inclination towards the drain point. Okay, and we'll take the drain pipe and connect to the proper drain location. At the time of installation, you need to maintain a slight inclination towards the drain point. This is also important, or else you'll get the leakage of water, condensed water in the room. Or else, if the water is available in that room side, it may increase the bad smell or the fungus and other issues.
It back slightly when installed.
So hope you got the idea about the window. This is a very small unit and it's like a plug and play. There is no installation procedure or list something. Simply you need to install. Just you need to take care for the inclination, and at the time of installation, after installation, you must check for any leakages. And if any leakages means that will increase, that will decrease the efficiency. Okay, so check for the leakages, and when you use this one, generally we are closing the door and window, because this will increase the load if you not close the door and window. Not only for this, even for other AC also. Okay, so this is about the window, the first type in the list, and that was just simple. In the next session, we'll talk about the other types.